let's get started. So, who loves build tools? Wow, that's actually many more than I thought. Who doesn't like build tools very much? Okay, this is a very brave crowd. I struggled with build tools. I was never really happy with the choices that were available, but I did have some ideas what to do about it. And about 2 years ago, I finally got around playing with these ideas, and it has gone somewhere in the last 2 years, so it's really come together, which is really nice. And yeah, we're here to talk about it. And so I'm Christopher Vogt. I'm a software engineer in New York, and you may know me from my work on Slick and from my time in the Scala lab in Lausanne.
And I am Kirillov Ilya. I'm a student at St. Petersburg State University, and I do CBT integration with IntelliJ IDEA.
So what is CBT? It's a general purpose build tool. It's optimized for Scala, but you can use it for other things too. And it really breaks down into 3 underlying things. One is just a bunch of Scala libraries for build-related features. A way to trigger Zinc, the incremental compiler, packaging stuff, all these things wrapped up in libraries. You could use them outside of CBT. Then a way to wire all these features together to configure your build, so to speak, so that compilation happens before you run things and that your tests execute before you publish. And this needs all to be wired together, right? But it's also a way to interactively invoke this functionality. You want to somehow from Bash or from your IDE tell, OK, now run this, or now publish it, or something like this. So you need these 3 kind of concepts. And well, why work on a build tool at all? As I said, I wasn't happy with what was there, and largely because either the existing tools were complicated or slow or hard to extend or kind of hard to get done what I wanted to get done, because I kind of had to push what I wanted into the model, the often very restricted model of what the tool was doing, or into the obscure API or way to talk to the tool. And I really think build should be simpler. If your build becomes the command center of your application, of anything, any scripting around your application, that's really nice, because it makes it easy in the language you use to just automate a lot of the chores that you might do by hand or that are kind of somehow hacked together. It should be really nice and really an enabler for you to concentrate on the real work, on the project you actually want to get done. So how does CBT help there? Like, why CBT? Why not something else? And one is it's really, really fast. It has a background process running constantly, so it doesn't need to class load the compiler or things like this. They are just running in the background, and you can call into it from the shell or from your IDE. It's also very powerful in that you don't run into these obstacles, and you'll understand in a little bit why. And it's very simple in that the building blocks CBT is made of are very few. There's very few concepts to learn in order to understand how CBT works and how to write builds with CBT. And it's also very familiar because CBT is really just Scala. It's just allowing you to use Scala to run builds. It's not a DSL on top of Scala. It's literally Scala. And that also means your type checker talks about your build. And the debugger allows you to debug the build interactively. And you can then generate Scala doc for your build file. You get code completion in IntelliJ. You can do print line debugging for your build when something doesn't work. So it's just how you work with everything else for your build too. And that's why it's also easy to learn, because it's just Scala. There are lots of examples. Could always use more docs. And apart from all this, a lot of Scala projects suffer from having a complicated implementation and really just a small group of experts being able to work on that code base, and the project really being reliant on these people, and this slowing down things or making it risky if these people leave, CBT has a very, very simple code base. Even Scala beginners can work on most aspects of CBT easily. There are some things with class loading that might be a little bit trickier, but most of the code is very simple to maintain. There's no monads involved and advanced concepts. So it's really intended to be a community project that people can contribute to, and there have been numerous contributions already. Especially plugins are super easy to write, but also just changing CBT itself is easy. So, and now we'll get to a live demo, because I mean, you're going to get a feel for what it is to play with the tool. And we'll do the live demo with IntelliJ. And really, while you see the live demo, it's important to realize that we'll be working with two different Scala codes. We'll be working with the build file, build/build.scala, which is similar to an SBT build file. It's describing your build. It's like there's a class that extends something, which has all the methods compile, run, and you're just invoking these methods, basically, to make your build do stuff. And then there's another file we create, which is the project, the stuff you are building, the main class with some hello world in there. So we're switching between the build file and the code we are building. So keep track of that a little bit. And I'll hand over to Ilya, who will be doing the demo with IntelliJ.
Okay, thank you, Chris. So for now, CBT support in IntelliJ IDEA, it's a main part of IDEA. So at the end of November, you will be able to use it. So then you create a project in IntelliJ IDEA. You can choose any object you want. It's like Scala. Oops. You can choose an SBT one, IDEA one, but now you can choose a CBT one. So let's do it. Let's call a project ScalaIO. And we have as CBT. To clone CBT, to get it, you need to clone it from GitHub to some directory. So, but to know how to IDEA to know how to use it, we should specify a path to the CBT executable. So let's do that. I already done that. It's here, path to the CBT executable, and let's select a suitable Scala version. So let's create our project. So it's being refreshed now. And let's wait until it refresh. Maybe, oh. Oh, let's refresh it now, like that. Yeah, good. So, in CBT, every model is just a build file. It's just a class which extends trait base build. So, and all methods here can be a settings or can be a task. So, for example, here it's generated by default by IDEA. We've got an settings which Scala version CBT will use. For now, it's 2.11.11. And let's create some very basic task to show it's, let's call it def hello, and it will just print, hello. Hello. And we can run it. So to run a task, we need, let's run it from terminal. CBT is good from terminal. So we've got a terminal, which in the same directory as the CBT project. So let's call CBT hello. And here it is. We've got hello output there. And now then we run it again. It will be much more faster because CBT is really fast. So now we've got only build file specification and we don't have a code to run. So let's do that stuff. New Scala class main object. Okay, and let's print something to see that it works fine. Print hello. and let's run it. So, as we can see, oh, let's hello world, I'm not confused. We've got an hello world here, so IntelliJ use CBT for running that. We've got hello world, and we run it again. It's very, very, very fast. And now let's return to our build file specification and see how we can else create some tasks. So it's just run. We can use default functionality of IntelliJ IDEA, which called configuration. There's also now a CBT configuration. So here we need to specify how it looks like, and here we need to specify what task will be run. So it will run CBT space run. Okay, and let's run it. Okay, totally works. We've got hello world. Also, there is very good way for running a task is just use a green play button here. So we can also debug a task. Yeah. And okay, let's add some dependencies here. It's very simple to use dependencies in CBT. We just need to override method dependencies. Oh, there. Oh, where it is? Oh, yeah, it's just a set of dependencies. So we need to use super to be sure that we have a Scala library inside our dependencies. And let's add, for example, some dependency to see how it works. And we've got add new sec, which use resolver. It's a stuff to get dependency, for example, from maiden. So let's specify where we would like to get from. And bind, and here we should write some dependencies. It's like an SBT, but at SBT we use persons notation, and here we can just use case classes. So specify a group ID, AE dot, caps lock, and we need, for example, let's use that dependency. It's div, and version is point. And then we have to reload the project, so CBT will download that library, and it will be sent to IDEA, so IDEA will know what we use that library. And it's done. So here we can see that in our modular settings, we've got that library. Here it is for ScalaIO modular, and close it. Oh, no. Here, and okay, CBT, as you clone CBT using GitHub, you need to compile it first. So CBT do it for itself. So then CBT finds every change, its source code, then you run some CBT task on your project. It just will recompile itself. So when it allows us, while we editing our project, just to edit CBT itself. It's very fun, so let's do it. We've got a base build, a trade, and let's print something here, like that stuff. So let's return to the build and run something. For example, we can run our main file here. So CBT now recompiles itself, compiles our code, and here they see output that we just used. So what just happened? CBT found that code of CBT was changed, so it recompiles, and then we are using a new patched version of CBT. It's really cool. And as BT, we have an opportunity to use a template engine. It's called GITA 8, which used in CBT. SBT, sorry. And SBT, they've got the same template engine. We can use it, so we can, while we creating an CBT project in IDEA, we can here choose default template, like contains only build file with Scala version, and we can choose any template you want. For now, there's only one CBT template, which is, but now it is going to be more of them. So, okay. Let's go back to the presentation, and I'll talk about the CBT IntelliJ integration. It was developed during this summer as my Google Summer of Code project in a cooperation with JetBrains team. It will be a part of official IntelliJ IDEA, so if you'd like to try CBT without leaving your favorite IDE, you don't have to install anything else except the core Scala plugin. It will be available at the end of November at the version 2017.3, but there is already available at the Scala nightly build, so you can just get the latest version of Scala plugin, nightly version, and just to use it. So the features, there is nothing you will not expect. Everything you will expect. It's, for example, from any from any build tool integration with IDE. It's creating an EPT project. It's running any tasks. It's debugging tasks or your applications. It's working with modulars. It's working with CBT source code. You can open CBT source code just like you opening, just like I showed before by working on your project. Or as CBT uses CBT for building itself, you can just import that project to import the CBT itself to IDEA and edit it separately of your projects. So, and Git 8 template engine supported too. So I'll give it to Chris. Yeah.
So, yeah, so the fact actually that from your build file you can jump straight into the source code of CBT itself is actually quite nice, because then you can explore basically, well, what tasks are there and how they work and how you use them, what the types are. It also allows you to just edit CBT straight away. You find something's not working properly or something, you can just edit it right there, and then you can submit a pull request, because the way you installed it is cloning it from GitHub anyways. There's no binary or something. You just clone the source code and it compiles itself when you first use it. And whenever you change it, it automatically on the fly recompiles itself. So what's the state of CBT in the grand scheme of things? Well, one is its happy 2-year anniversary, because it's like been going on for 2 years now and it's been come quite a long way. And the core is feature complete. You can express any kind of build I've run into. And there were quite some discoveries that had to be made on the way. Like the last pieces came together maybe a year ago when I realized the solution for a bunch of concepts that until then I didn't know how to do. It's all the features that you could think of: compiling, running, Scala doc, testing, dependency tree, forking the JVM when you run stuff, dependencies on Maven, but also you can depend on Git or Git repositories or directories. There's the looping when files change, that you redo some task. There's a very clean expressive model for, well, expressing multi-project builds, expressing task scoping and cross builds and stuff like this. We'll get to this. It's one simple building block that makes all these things happen, which is actually very nice. The code base is still very small and simple, just like 7,000 lines of code or something. Fairly straightforward code. We want to move more code over from the core into the libraries that are separately usable. Some cleanup would be good, but it's already quite easy to follow the code just along. More documentation. There is already a quite good number of plugins, and it's also growing. So these definitely exist. I think there are a few more by now. You would miss play support if you're looking for that, but it shouldn't be too hard to build, actually. Plugins are very easy to create. We'll create one in a second. IDE support is now available for Ensime and for IntelliJ. And I really encourage you to try it out. But let's zoom out a little bit. Let's think about it conceptually. What makes builds hard? There are a number of things, but one very prominent thing is the graph structure involved. Let's look at it. So if you call CBT run, you invoke this method run, which will invoke the method compile, which will invoke the method's class path and Scala version. So you have this graph of tasks or settings depending on each other. And in CBT, it's all methods, so it's the same thing. And then these things can call out into hard functionality in the library. Okay, but this graph is irregular, right? It's a directed graph, but it's not a binary tree or something. There's no like repetition in that structure. Compile run calls compile, compile calls the class path, and it's a pretty complicated graph after a while. And working with graphs like this is hard because we can't like understand one concept and understand the entire graph. We have to keep the relationships between the individual pieces in our mind. And this is one aspect that also makes SBT and other build tools complicated. It also makes things like Git more complicated to learn because you have to remember the Git commit graph. And inheritance, similarly, you have to reason about a graph. But it's not only this. You also, in a build, you have like multiple modules, and they may connect to each other. And so the graph gets even more complicated. And on top of that, we're even patching graphs. We're taking these graphs, and we're creating different variants of them for cross builds for different Scala versions, or for Scala.js with with optimizations on or optimizations off. We're kind of creating these like different versions of our world, once with this version, once with this other version. So we have to keep track of this as well. And in a way, this is intrinsic what builds are like. So we can't really get rid of this. So how to not get lost despite this? And CBT's answer is really, let's use a language to talk about these DAGs, these direct acyclic graphs of dependent tasks that we understand, that we already know. And not only you know the language, your compiler knows the language, your editor knows the language, your documentation generator knows that language. And I'm claiming Scala is a language with which you can talk about graphs and patched graphs. And let's look at how. Right, and it's really Scala. It's not a DSL written in Scala running on top of Scala. It's literally Scala. So the JVM is your interpreter. It's not something written in Scala that runs on top of the JVM. It's literally the JVM executing our task graphs. So let's look at a few methods. Def x equals 5, y equals 6, z equals x plus y using both of them. This is a graph, right? We have a graph of dependencies. So we can use that to describe builds. Compile can be a method that calls class path, which can be a method. And in order to patch these graphs, in order to, for example, adjust the Scala version, well, we can create patched graphs by wrapping it in a class, subclassing it, and overriding one of the fields. So now we have a mechanism to describe graphs and patch graphs, which is the thing we need to describe builds. So this is basically the essential idea that CBT was born out of. And then this idea was taken as far as possible, and then it turned out that it would actually was possible to take it all the way. But this is using inheritance, right? Isn't inheritance hard? Aren't we trying to avoid inheritance? Yes, if we can avoid irregular graphs. But in case of builds, we can't really avoid irregular graphs. They're an intrinsic part of what builds are. So the best we can do is use the language for irregular graphs that we understand, which is inheritance, and map it directly onto it. But what we can do is keep the graph as small as possible. Not everything needs to be in this graph. One is that in CBT, this graph is really just the connections between things. No logic lives in this graph. All the logic is in libraries that the graph essentially calls out to. The graph is really just the wiring. And the other thing is, sometimes you don't need to put things into the graph. A lot of the plugins in CBT, they don't add lots of names into the graph, meaning into the class. They often add a single name to the class, which is itself an object which has more stuff in there. So you can use composition instead of inheritance to basically add more functionality. So there are ways to basically segregate the graph or keep the graph small. And these are the mechanisms that CBT's structure or architecture uses. So let's do a few more demos. One is, so what are plugins in a world where builds are classes? Well, let's just write one. It's easy. Let's go back into the build file. So let's say, okay, what do plugins do? they add new tasks, or they might somehow alter the existing tasks, right? Let's say hello wouldn't be in our build, it would be in a plugin that we want to reuse in multiple builds. So let's just take this out of here, put it in a plugin, trait my plugin, and then we mix in this plugin. So now we have a reusable part of our graph we can just mix in, right? And we can put this trait in a library if we want to consume it in multiple builds or into a separate module that our builds consume. And builds, so this build folder itself, like the entire thing, is again a CBT project, meaning you can write a build file for your build file in which you consume libraries which will be available for your build, not for the main project, and so on. So it's very easy to write a plugin, and then if you want to access any of CBT's features in this plugin, you just say with, no, extends base build, or you can do a self-type. But now the plugin can access CBT's internal features, or you can extend some other plugin. Okay, so write a trait, that's a plugin, done. Let's call it, just to see that it works. Terminal. Hello. Yeah, oh yeah, and we still have this thing in CBT itself. Let's take this out. And let's recompile. You can see how the first thing that happens here is that, where are we here? That CBT compiles its own source code again. Okay, so again, this makes it really interactive. So another thing is SBT has a feature called task scoping. And also a lot of build tools allow you to have multiple modules in a single build. And for a long time, it wasn't clear to me how to do this in this world where the graphs are inside of the classes. Because there's one class with one set of methods. How do you swap out the versions, something like this? But turns out there's one single feature in Scala, the language, which allows to make this happen. Basically nesting. So what you can do, is when we write a new task here, def my task equals, well, 5 returns some value, right? But we can also say new object, or I mean, now I'm just creating an anonymous class. We could just take a named class too. I'll get that in a second. But my task and then def foo equals bar. So from the command line, you can not only call the top-level methods, you can call into the object graph. So you can say, hey, my task dot foo. Oh, this doesn't exist. So now you have a structuring mechanism, and this structuring mechanism can be used for a bunch of interesting things. Like basically, this is the building block needed to implement a few things, like scoping. For example, you can say, hey, let's say we want an alternative universe of our build in which we pass compiler flags we usually don't pass. And one that is very helpful is xPrintTyper. So with xPrintTyper. And in here, so now we say, okay, we want a new build. So we're kind of creating an alternative version of this, right? We're patching this. And now, so we have a subclass of build, right? Which now we basically forked our universe into one direction and replaced something in this universe of configuration keys. And we also gave it a name. So now we can just say, hey, okay, if you do CBT, let's do CBT clean, so we force it to recompile. If we do CBT compile, if we would do CBT compile, it would just regularly compile and the compiler flag is not on. but now we reach into the with x print typer and call compile in this build class, where now this compiler option is applied. And now we should see here the debugging output of the compiler. So this really allows scoping in a very simple way. And it's not only for scoping. You can put a lot of stuff into these defs. You can have unrelated build classes, multiple different build classes for your different sub-projects. We can have a def sub1, which would be one sub-project. And we say, OK, new sub1 of context. And we define it as class sub1. And now in there we can, let's say, override def project directory slash sub1. Now we're referring to a subdirectory in which we have our submodule. And we just put it here. So now we can do something like CBT sub1.compile. Yeah, so nesting can be used for, nesting combined with subclassing can be used to basically create different versions of the universe, which is essentially task scoping. It can also be used for cross builds with different Scala versions. You can even have a def that has a list of different builds and do something there. It can be used to support modules. Few other features that CBT supports, unrelated to this, is let's just get rid of this. So here we added a Maven dependency. By the way, the syntax SBT uses works as well, just to make it easier to copy and paste. But I think by now people generally like constructors more than DSL, so that's at least the recommended mechanism. But you can also add dependencies, I think I mentioned this, on directory dependency. So now you can just give a directory path where you have another CBT project and use this as a dependency in this build. Or you can have a Git dependency where you specify, oh, this is the place where some Git project is, and then you want, I don't know, master or something like this. So you can reach into sources in these different locations. They have to be CBT builds right now in order for this to work. And yes, oh yeah. One thing fun is, so if you want to have basically a source dependency rather than a binary dependency on a code base that's not built with CBT, there's a trick you can do where you create a fake, like basically an empty project, where the build pulls in sources from GitHub, which is also possible, but then it has its own build file for these sources. So you can make a fake CBT build for a project that are usually built with SBT. And a lot of build files are pretty simple for open source libraries. Not all of them, but many of them, so you can easily consume them in this way. Yeah, and oh yeah, haha, one last feature. This is a fun one, actually. So in here, we added this method xprint typer because we wanted to see the typer information. But there are lots of compiler flags and lots of things you just want to do as one-offs. You don't really want to add a method for that to your build. Xprint typer seems to be one of them. So you kind of just want to, from the command line, dynamically reconfigure your build rather than changing your build file. So how do you do this when the build file is just Scala code? Well, I mean, we're on a build tool, right? We can create and compile code that is somehow fed from somewhere else. It doesn't have to be handwritten. So CBT uses that, and you can basically, you can take this, and we can include this plugin with command line overrides. And now, command line overrides provides this task called with, which produces like an ad hoc subclass of your build where stuff is overridden, just so you can ad hoc one-off from the command line, just put something in your build. So actually, let's clean first. Whoa. clean, so because if we don't clean, then it doesn't recompile, so we wouldn't see the effect of the compiler flag. Okay, CBT with, no, did I not copy this? Oh. Okay, CBT with, and now we can give some task like, I don't know, run or compile. So it's really kind of a wrapper around a task that injects some extra stuff. And voila, we have this ad hoc override as well. Yeah, so this is really all we got. Basically, CBT is a mechanism to allow you to write your builds in Scala and have like vanilla Scala experience with it. And there's an active Gitter channel where you can ask questions. There's an active GitHub project where a lot of people have contributed plugins. We're on Twitter as well. And yeah, join us for the next generation of Scala builds. Are there questions? Yes, Daniel.
So you showed, you talked about DAGs.
Yes.
In particular, regular DAGs, but all the graphs you showed were actually trees. Like what actually happens when you have convergence in a subgraph? For example, like you perhaps might have two tasks that are dependencies of a first task, and both of those tasks depend on compile. So how do you detect that convergence if you just call it functions?
That's a very good question. So to repeat the question, the examples I showed were graphs that were actually trees, they didn't have nodes where there were multiple incoming dependencies. So I didn't show anything where, let's say, I generate Scala doc, which requires that code is compiled, and I run the test, which also requires that code is compiled. The answer there is, in CBT, every task on its own is responsible for caching, meaning it's a requirement for tasks. You can execute them as often as you want, and they're idempotent and cached. So the tasks that would do compilation would manage a cache with a timestamp. That means it can be called like 10 times or something during execution of the graph, and only the first time it will do something. Later, it will just be no ops. That's the answer for CBT. Yes?
In your example, you had a method which returns string, like hello, which returns string. Do you have actually some kind of a task or any to-unit thing which actually recognizes that you need to bring this string, or what to do with string?
So right now it's hard-coded that there are few things for which I wrote this a while ago. I think it might check if a certain method is there, run this method on this type. Otherwise, just do the toString representation and print that. Type.
Return arrays, like it won't return the array.
Let's try it. All right. So let's take a. Yeah, it would not. It would just do the toString thing for array, like when you print it in the REPL or somewhere else, right? There's one behavior which I guess could be discussed, which I'm still not sure if it's a good idea or not. But if this thing is a build, it will. Well, if this thing is a single build. No, if this is a list of objects, I guess, then, and you do basically a method call on that list, this method will not go to the list. This method will go to all of the objects. which is where the command line way to call things behaves differently than Scala behaves, which one could argue that it's surprising and should be avoided, or maybe that's useful because this allows you to, let's create a list of builds with different Scala versions, and then you can just compile and run and publish all of them.
What if you just have like a different operator other than dot in the command line?
Yeah, a different operator is maybe something that might be a good idea. And there, I guess it's in a way it's similar to what some of the lens libraries are doing as well, where they have something dot each, and then that changes the behavior of what things mean. Yeah. Let's be part of the discussion. Yes, Guillaume. So the question is, so SBT 1.0 has a server mode, so other tools can talk to it. Well, CBT, there's no like demo of how this working, but in CBT, the calling it as a process is very fast, and you can have tasks return. Yeah, the output is just text, so you can have your task return JSON and parse it. So that's a way how you can maybe you can speak about how exactly the IntelliJ plugin does that. It talks to CBT to get things like the dependencies and things like this, right?
Yeah, okay. IntelliJ IDEA for inputting project just running special task, and which the task return XML, which contains all modulus and all modulus information like project directory, all the path to all jars for dependencies and etc.
Okay, I guess it's exactly what I said with XML because that's what IntelliJ understands better. Yeah, it's a. Let's chat about this after the talk. Yeah. Yes.
Actually, two questions. So, first question: what happens if the task fails badly, crying, bleeding, and throwing exceptions?
You get an exception. If the task fails with an exception, you'll get the exception, which points all the way from JVM startup through CBT into your build file, and you get the stack trace.
So there's no like internal exception handling. It will just throw stack trace.
It will give you the exact stack trace, which actually I think is a good thing because it allows you to really point to where things come from. Nothing's hidden, and you can even see where it went through CBT. I think it would be nice if there would be some kind of maybe color coding or something to see this is part of your build, this is part of CBT, this is something else, but...
Yeah, and second one is, so will there be the same case like with SBT prior to 1.0 when we were bound to some specific version of Scala in our Scala build scripts?
The goal is no. Right now it is 2.11. I think I was under the impression until recently that you can just choose any Scala version, but there's a bug in there which prevents you to choose anything other than 2.11 for the CBT build scripts. But I think it should be not too hard to fix that bug, and then yes, you can have a build for your build, and that build says, oh, the build is built with 2.12. Right. The question is, how does it work with these different versions with third-party plugins? The answer is right now, CBT plugins, the two answers in a way. One is CBT plugins right now are consumed as source. So that makes some things simpler. So you basically you point to a GitHub repository or something. But then again, also, actually right now, almost all plugins are part of CBT. So it's actually encouraged to merge your plugin into the main CBT code base and have it just live there, which now means it's actually part and compatible. But you can totally have it separate.
At some point, it would just go crazy with the size.
I mean, how many plugins are there for SBT? 100 maybe? Maybe 200? But, and the thing is that these plugins, a lot of SBT plugins have a lot of wiring code just in order to translate from Scala methods and stuff like this into this task name world of SBT, and all this wiring logic goes away. And generally what's encouraged is that the plugin itself doesn't have a lot of logic. This plugin itself, and the real logic should be in a library that's separate from the plugin. So for example, for ProGuard or something like this, the logic that calls ProGuard within the CBT plugin is a separate library that just knows how to call ProGuard. And then the CBT plugin is really just little wiring code that puts it into the graph. And with this structure, I think it's, it should work very well. Yes, Trond.
Yes, differences with SBT are
Oh.
but how does it compare with Gradle, except in Scala? Because it seems that the principles are quite the same.
I haven't looked enough into Gradle to really, so the question is how does it compare to Gradle? I haven't looked into Gradle enough to really tell. But for me, using the same language for your build files, like for your main project, is actually a major advantage because you're learning a lot of these libraries and you learn how to use them very well. And it's really nice if the knowledge transfers between your builds and your main code. And you can also use your own little libraries that and your own helpers and stuff in everywhere. Yeah. Yes. Can you compile it with Scala native? No, right now, no. For several reasons. One is that it relies on class loading, and it relies on basically the way CBT bootstraps itself, where it starts from source and then compiles itself in multiple different steps. There's 3 different layers, and then there's the build as well and different builds. Anytime you transition one of these layers, also when you transition from the build file into the main code, you're basically switching class loaders. You're switching like a class loader universe, and every time you switch, you do this via reflection. And so you need reflection to transition between those worlds. Because I mean, you want to keep your application logically separated from your build, right? Your build file. So they kind of have to coexist in the same JVM, but separated from each other. Yes, Daniel.
I'm going to monopolize more of the longer time.
Sure.
So the CBT process is resident in the background, and I would assume it's sort of a global process that's resident for all builds. But even if it's not, I have some builds where Zinc itself, like just compiling the source code, Zinc will take several gigabytes of heap space of memory just to like actually run the compilation. And because of bugs in URL class loader, like that actually ends up leaking over time. Like if I do this with SBT, for example, I actually have to kill SBT sort of a few times a day. Otherwise, like I will just start crashing. Now I would assume CBT is more efficient at some of managing some of this stuff, but like ultimately some of these are bugs in JVM and bugs in Zinc. So is there a way to like force the resident process to restart?
So the question is, with the resident process, what if resources are leaked by some things running in these things? Like, don't they leak into this resident process? And yes, if there are things running that leak resources, they leak into the resident process. However, there are multiple ways to circumvent this. One is, instead of running, I don't know, CBT run, for example, which uses the process and is very, let's time this actually. So CBT run is fairly fast. You can do CBT direct run, which will avoid the resident process and just throws away the JVM. But obviously, it will take longer. Like, it took a second overhead now. Sorry?
That's still faster than SBT.
Yeah, I know. The instant, like, it's faster than the startup time of the console of SBT, I think. But the other mechanisms are that you can also just fork the JVM. Actually, Zinc itself. No, you can fork the JVM in these situations. and just run in a forked JVM within. So basically have the main orchestration done in the resident process, but then only fork the sub part that you think is leaky. But there is some global mutable state in the JVM, and this can lead to problems. One of the things, for example, is that the JVM captures the current working directory at startup, and you can't get away from it anymore. So basically, in CBT builds, you can't use the JVM's current working directory because you never know where CBT was started. You just have to use the one that CBT manages instead. There's also some stuff with like swing. Sorry? Environment variables, some stuff with system properties. There's some things to take care of. It's all the same problems that other container frameworks like the nice thing is this is not the first approach to basically run Java applications in a resident JVM in a containerized way. There's like actually a lot of knowledge that can be reused from OSGI and from some of these container solutions that just transfer. When we ran into a problem with CBT, we could look up, oh, that's how they do it in this other open source solution. And then, yeah. The question is, how does this interact with Java 9's module system? I don't know. I think that question applies to a lot of applications. How will this work? So we'll see.
Most cases, the answer is poorly.
Yeah, most cases the answer is poorly, yes.
Does it support parallel dependency resolution and download?
So right now, the dependency resolution is sequential. The goal is to, and we still haven't gotten around to this, is to integrate Corsair into this as well, which should probably be the easiest. Yeah, that's the answer, I think, and then Corsair would take care of this. Yes?
You mentioned submodules. How do you dispatch your builds into your different parts of your build for the submodule into different have shared code in the root that will share.
Yeah. So the question is, how would you handle multiple modules? How would you share things? One of the examples, these are the example projects in CBT. There's a multi-combined example which has a single build file that has a lot of different sub-projects. So here's the main build. It has sub 1, sub 2, sub 3, as different subs, and then you basically can say, oh, in sub 5, I have a dependency on sub 4, which again, in turn, has, I think, some things inside of it. Does that answer the question? Like basically, you can. This is the main interface for you. Basically, this is what you interact with from the shell, and then in there you can have things nested inside of it, and they can have dependencies on each other. Does this answer?
Yeah, you're describing these dependencies. That's part of the API you built, right? The dependencies on other projects. That's part of it.
Oh, so in this case, there's a trait that's mixed into all of these into all of these that you need, and then the submodules that something else wants to depend on are defined there. And then because it's mixed in, for example, here, now sub 2 can add sub 6 to its dependencies. By the way, this list of dependencies that can be Maven libraries, can be other builds, can be Git dependencies. It's all the same type. It's all like, so you can just put them all in there. It's the same.
Also, I mean, can I start using like futures and stuff like that? I mean, kind of this question, but if I know I have like a bunch of modules that are loosely related to each other, and I can combine them together, and then join them to build another module or something like this.
Sure, you can it's just Scala, so you can use futures if you want to trigger things in parallel. Yeah. Yes.
Can you mention Rapid?
Yeah. Let's see. Whoa. should be just CBT REPL. What do we get here? Oh, I think we have to use direct right now. And there's some, yeah, so now we're in a REPL for, I think it's, what do we have? Main, array. Yeah. There's some, most of the interactive tasks that have to establish basically a console for the user to write, you have to use the direct mode for now. Because through the background process, this is more complicated. There's a solution which is already implemented for some. I think for asking for a password when packaging stuff and signing it, I think is implemented that it doesn't need direct anymore. And I think other things could start using that mechanism as well, but it's not been transitioned to the others yet, yeah. Okay, are there any more questions? Yes.
Can you define a task with parameters?
Oh, the question is, can you define a task with parameters? Right now, yes and no. Like, what doesn't work right now, but we should totally add that, is something like this, where, I don't know, how would you do this? You would say, my array, I don't know, 5, but that has meaning in bash, so maybe this. This does not work. What you can do is this, and in here, so this context object, which basically gives you access to things like the current directory and things like this, there's a way to access the arguments as a sequence of strings. But it would be nice to type save this. There's actually an implementation of this logic in Ammonite, which maybe we can carry this over or something. So, yeah. If there are no more questions, then thank you very much for the attention.
Thank you.